Bill, get started.
That's all taken.
All right, so we're gonna go ahead and get started here. Out here a little bit. First of all, thank everybody for coming tonight. Beer and food in the kitchen. Feel free to get off and talking. Get whatever you need. There's plenty of it over there. With that, we'll get started. For those of you who don't know, my name is Selma Hart. I'm an exclusive principal with Solid Consulting based here in Chicago. So we are could be a obligatory sponsor club here. We are a consulting firm, a business and IT consulting firm. Marketing specifically, we do a lot of customer facing web application development right out of our Blizzard Center here in Chicago office. Lots of work on the modern website, doing a lot of stuff with React, lots of work as well as some native iOS and Android stuff. If you guys are interested in learning more about Solid, feel free to grab me at where I'm talking here, and we can have a chat. So with that, let's get going. I don't know if any of you guys were at JSConf back in 2013 or remember when this new React library was coming out. You know, there were a couple guys down there that kind of gave a nice talk about it and were presenting some of these new ideas, particularly around JSX. These things were getting some interesting reactions out of the crowd. There's a lot of big news from the JavaScript community out there. That had some interesting reactions. Ben Alman, Gregor Grunt, Middleton, I'm not sure who he is, but I'm sure like he's tweet about it. And then Rick Walker, who was one of the guys on the core J3. So lots of interesting reactions coming out of it. It took people a little while to warm up to the idea of JSX and putting HTML or XML, whatever they want to call it, into the JavaScript. Look at the repository now, it's still not right for itself. It's got some community attention. It's got talked about. It's in the top 10 JavaScript projects on GitHub right now. So what we're going to talk about today, we're going to talk about the Flux architecture. We're going to give you guys a quick overview of what it is, how it works. We're going to talk about some of the core components that really make up the Flux architecture. We'll go into just how we can integrate some of our APIs with this Flux architecture. So I'm talking about how we're going to integrate our REST APIs and some more asynchronous actions that we're dealing with. And then I'm going to talk about some of the patterns that we've found useful here on our team for sort of scaling this architecture out. What are some of the quirks that we need to watch out for? What are some of the items that we need to be careful of? So what is Flux? So this is straight from the Flux website. Flux is an application architecture that Facebook uses for building client-side web applications. It complements React's composable review components by utilizing a unidirectional data flow. It's more of a pattern than a formal framework. So when we talk about Flux, it's important to note there is nothing specific about Flux. There's nothing specific about Flux that ties it to React. But we could use this Flux architecture with any type of front-end type framework we wanted to. We could use it without a framework at all. Flux is really just a pattern for building these responsive UI applications. That being said, it really does complement React's composable view model very nicely. It fits really well with that structure. So what are the core components of these Flux applications that we're going to build? We've got our actions, we've got our dispatchers, we've got our stores, and we've got our flows. So let's talk a little bit about how these things kind of wire up and what the interactions are. So when we talk about views, I think everybody here has done some type of work with React. Views are really just our compositions of components. We represent how we want our state to appear on the screen. What do we want the user to see? Ideally, these views within the Flux architecture are stateless. So there's no real data that lives within these views themselves. The views are just representations of data that's coming out of the source or coming down from the parents. Ideally, all data is coming down from the parent or the root node of our application. So we're not pulling, within some of our child views or whatever we might have, we're not pulling any data in from external sources or global sources, whatever those might be. That makes it really easy to write these small isolated views that we can use in the test that compose and reuse in other places as well. Also with the flux architecture, it's important to note that for the most part, data should not have to flow back up the tree from our child. We'll talk about that. So the next big piece of the flux architecture is our stores. So the stores are where all of our application state and data are going to be. These stores are going to represent a domain area of our application. So if you're familiar with a framework or library like Backbone and its models and collections, the stores are meant to be a little bit more than that. So a single store might have multiple related collections contained in that, multiple related models. It's more about representing the entire domain area that the application needs to be considered. There's no understanding of the data presentation stored within the stores. The store does contain some view state, just because this is where all state lives, but it doesn't have any knowledge of what the views might be doing in that state, how they would be presenting that views. These stores do listen to events that are coming down from the dispatcher. So one of the big responsibilities for the stores is to listen to events coming in, determine what events that the store, or action, I should say, determine what actions the store is interested in hearing about, and then handling those appropriately. So making changes to itself when those actions come up. We'll talk a little bit more about actions. And one thing that is important to note is that these actions that the store is being fed, it can't necessarily care what actions are coming. These stores are going to receive every action that our application creates, dispatcher. So where those actions are going to come from, those are going to come through our dispatcher. Our dispatcher is going to be our singleton event processing our application. So all of the events that come through the dispatcher, they're going to be sent out to every single store that is registered in a function with this particular dispatcher. And anytime we have an application, we are only going to have one dispatcher per application. So that's going to provide a single contact point where all of our data, all of our events, all of our changes can kind of flow right through. And we can let the stores wire up to those and handle them. Finally, the last major component of the flux architecture are actions. Actions are pretty simple, very analogous to events. They're just an object with a type property, and that's some data type to them, where we type in the data together, describe how we want to mutate our store. They describe something that happened. The store can then mutate itself in response to it. These actions are typically created by an action creator. So an action creator is really just a utility for sending these actions off. All of these actions that we talked about are going to be handled by the dispatcher. So these action creators just handle this, tell the app dispatcher, hey, something happened. Here's what it was. So taking another look back at this, we can get a little bit of a view on how these actions kind of represent the core turning point for what goes through our application. So when we look at this diagram, these actions could be either something external to the app, so something like an asynchronous API call coming back, or they could be something that is triggered by a view. Maybe somebody clicked the button on the page, or somebody sent me a message, read an email, whatever. So what does this allow us to do? What does this give us? Well, this allows us to really build our views in a way that they are completely stateless. We can get away entirely from any state living within these views. We can get away from any global state. We can get away from any mutable state. All state can just be pulled out of the stores. And the views are just a representation of that state at any given time. These views no longer have to be responsible for responding to changes in data or propagating data changes back up. You get a nice uniform, unidirectional flow through our application. And these are just the end results. So you start thinking of our views now as pure functions, where these views are just going to take a set of inputs, and given that set of inputs, they're going to produce our output, which is our HTML. Given the inputs coming into it, as long as those inputs are the same, you can expect to get the same output every time. There's not going to be any influence laid on our views by external data sources or configurations from outside of the parent views or whatever is coming. This is a really awesome piece of this Flux architecture. It really makes thinking about these views a lot simpler. So let's talk about kind of what this looks like in a reasonably sized application. If we think about something like a mail app, we might have a core component that's kind of managing and composing the whole thing. We might have some folder views over on the left-hand side that allow the user to toggle between some different pieces, along with maybe a message listing in the center and a message display on the right-hand side. So lots of components, lots of views on this page that we might want to think about breaking things apart into. So if we start looking at what this hierarchy might look like, at the top we can have our mail application, and then that can fan out and manage its three separate components: the folders, the message list, and the message. Those in turn might manage their own list of components, depending on the data. So this is a nice representation of the hierarchy of how we might consider building this application. So when we start thinking about the data and how that stuff all comes together, things get a little bit messy. Right? So when we think about what happens when a user clicks on a folder, well, then we have to update the messages. So maybe we have to think about updating the messages on the right-hand side. What about if an item clicks a message from the message list? Well, then not only do we have data that needs to go back to the folders, but maybe we have an unread message count that's displayed over on the left-hand side. And we have to send that data over there, but also send that data to the message view so that it can update itself and know what message that it needs to show on the page for the user to look at. So things can get messy there pretty quickly. Start getting start getting these spaghetti pieces of wiring going all over your application. If you're not careful about it, you'll be paying attention to those flows.
What is the message going to inbox?
So if we had, let's say that in our inbox, so we've got that display on the left-hand side. Let's pretend that displays a list of unread messages. So if I click a message to open it, it might have to tell itself that, hey, now I'm marked as red. You need to update it now. So that kind of brings up another interesting point. When we talk about this simplified data flow of, if we're just popping data through our application, well, what happens when we fetch it from an asynchronous source? So this is the architecture as the Flux website describes it on its GitHub page. So they talk about sort of the interactions and what's happening between these different components. As we can see over there on the left-hand side, we've got our action creators, which are actually responsible for performing our asynchronous calls, loading data from these external sources, then creating actions with that data coming back in. So that data can flow through the dispatcher and ultimately down to all the stores. I'm going to talk about one quick change that we've kind of made within our own teams as we're building these applications. We've actually moved our web API requests over to let the store manage those. That was something that was a decision that we kind of made as a team. It's worked out pretty well for us, particularly when it comes to managing things like cache data, or data that might not need to make around it. So, or I should say actions that might result in a round trip to the server. Rather than having to build some logic into a web API handles, we can keep all of that core business logic isolated at the store level, and that those are responsible for making these decisions on whether the requests need to be made. And it doesn't really change much from the perspective of the Flux architecture as a whole. Because at the end, our stores are just emitting changed events that our views can then respond to and recognize themselves. That being said, that is just our opinion. We can talk about some of the implications of that as well. So with that, let's take a quick look at an application and kind of what this actually looks like in practice. So I can see it here. So we talked about kind of our, yeah, let me change the split here. No, better, still too small. Okay, next, good. Cool. So yeah, so let's talk a little bit about our view hierarchy, and then we'll kind of go into the how the Flux architecture kind of plays into this and how data is coming to our application. So our core component here in this reasonably simple app, there's still enough going on here, a lot of technical concepts going through. Core component here is our mail app component. So all the mail app component is going to do is grab data from its state and send that data down to the appropriate children. So in this case, a folder list, a message list, and a message. The message list and folder lists are relatively simple. They're just going to iterate over those message items coming through and list them out. Same thing with the folder list. So just take a quick look at what this looks like on the screen. And you have to ignore my awesome style job here. It's not part of the presentation. We can just see what that looks like. So we've got our folder view, our message list view, our messages. So how about this data coming in? How are we kind of starting this piece off? So we've got our views here. In our main view, what we'll see is that the first thing we do when our component has actually been mounted on the page is that we issue this action that says the application has started. So one point I'll mention later on is that when we talk about our actions are always they're always past tense. So an action always represents something that has happened. You'll see a lot of variants of that out in other people's repositories. I think it is good to just agree on practice amongst your teams or whoever you might build these applications with and stick with that. Using these past tense actions, just kind of one thing we found is worked well for us. So this application started. That's the action that we're going to send off once our core component, our main component, has mounted. So if we look at what happens when we issue that, we're just going to send that action off to our application dispatcher, which is going to say, okay, here's an action with a type that says the app started. No real data to send along. This one's pretty simple. No need to do too much on the data side. The store is what's going to handle worrying about that action coming in and say, okay, I know I need to do something with that action. I need to go get my data so that I can show it on the page. So like I mentioned, anytime you wire a store up to a dispatcher to listen for events, that store is going to be fed every event or action coming to the system. It's up to the stores to decide based on the individual events what it wants to do with those, or which ones it just wants to discard. So in this case, we've got our first event or our first action that says, okay, the app is started. I need to go out and get the folders that the application cares about. So this is where we're going to start to see our API integrations and start doing our asynchronous actions. We've got a pretty simple API that's just kind of built into the app. Some stuff and set timeouts. There's not a whole lot going on there, but I think the core point, the concept is still able to illustrate itself with saying that we're going to perform some asynchronous action of going and getting some data. Once that data comes back, then we'll go ahead and emit our change event. It says, hey, something has changed within my store. Any views that care about me as a store or care about the domain area that I represent, you need to know about this, and you're probably going to want to update yourself in response to that. So this is where we can kind of circle back to our views again. So our store has said, I have changed. Now, within our mail application, in addition to the component mounting issuing the application started, one of the things we did was we sent off a change list to our mails. We said, okay, here's some callback that we want to be fired anytime any piece of data within your store has changed. Once that change event happens, the only thing we're going to do to ourselves as this view is update our own state. So in this view, we have a simple utility method that just returns the entire state of my component at any given time. That state itself all lives within this mail store. So on this mail store, we've exposed utility methods for grabbing the folders that we want to display, grabbing the selected folder if there was one, and grabbing the selected message if there was one. So one other point to illustrate about this getState utility method here is that this getState method is the same method that we're using when we set up the initial state on the component. So one of the things you might see as you're going through either applications that aren't using Flux or maybe some variants of the Flux architecture or the Flux pattern is that they might have a getInitial state method. This is really just the ES6 representation of that method, but within that, they might be kind of defining their own placeholders for what state might be. That can get confusing later on because at some point you might render these components either in, say, a server environment or an environment where all this data already exists and you're not going to get any change events from the store, so that you might not ever know that it needs to update itself. It's much easier to just keep one consistent method that says, okay, here's where all my state is going to come into from the stores, and we're going to use that every single time we update state. So finally, as this data comes in, we showed that we're pulling the data from the state and just passing it as properties to our child components that are going to make up this view. As we go down into the child components, a couple things to note with these is one, these don't have any knowledge of what that store was. These aren't wiring up chain event handlers. These aren't pulling data directly from the store. The only thing these child views are doing is looking for data coming down as properties. Anytime those properties change, that's a state change to our view, to the data coming in, so it's going to re-render itself based on the inputs and just produce its output again. Or pass that data in further along down the line to more child views. The thing these views will do, though, is fire off actions to trigger other indications in the store. So if we look at this folder list item view, it has a click handler on a folder that is able to fire off an action that says, hey, the folder changed. This action is a little bit more interesting because we're also going to pass the ID of the folder that we changed. and we can see what happens once we click one of these other folders. We'll fire off our action that says, okay, our folder changed. Let the action creator fire off the action that says the folder changed. Let the store listen to that action coming in from the dispatcher that says, hey, the folder changed. You need to update what the state of the folder was within your application state. Then go ahead and emit your change event that says, hey, something changed within my store. The user going to look at that and say, okay, I need to pull all state back in, rewrite my lesson. Any questions about these patterns and kind of what's going on here and how this works?
As you build on apps, how do you find out the best way to split when you need new storage?
Really, the best, I think it's really a judgment call. You know, it's about understanding what the domain areas are within the application. And one thing I would recommend is trying to avoid the cross dependencies between stores. I think that to me is a sign that your domains are too related, and you might want to think about joining those together. But if you find yourself a lot in the store and you find pieces that are completely independent, that's a good candidate for splitting it out. There's not going to be really a hard cut or a hard cut and dry answer to that question.
What's the biggest cost benefit to going to Flux or transition to it?
So for us, I think it's been the simplicity about how we're really representing these very dynamic applications and just being able to get away from having to worry about, okay, how do the views represent these transitions between state? So if we think about just clicking a better example within this quick application here is clicking a message and marking it red. Well, if you, not saying every other application is going to be like this, because there are certainly ways to not have it, wired all over the place like this, but without Flux, you might have to do something in your view that says, okay, I clicked an application, or I clicked a message to read it. Go tell the store that this message updated itself. And maybe there's some other side effect that happens as a result of that. Maybe that store needs to make an API request to mark it on the server as red, and that could come back as failed. And then that data needs to come back into my views, this view as well as the messages view, and so they can both update their counters. That action fans out really quickly. It gets tough to manage things like cascading events through the system, and where that fan out goes, and what happens if one item fails within that tree. So with this, we can easily say, okay, we're just going to put everything through the central hose. Let the events come through our stores, let the stores be responsible for all of that data, all of that state, and then just let the views fan it out down to its 100.
As a help testing?
That's an interesting question. It has in terms of being able to write really isolated components, particularly as we get away from views. So we can write a lot of really small pure Node or pure JavaScript modules or libraries that just handle our business logic and perform a lot of the the core business functionality that we need those to perform. I'm not sure that's quite so much a benefit of Flux or even React as it is so much a benefit of using patterns like browser archives, common JS modules, and thinking in simpler terms about it. On the React and Flux side, testing stores is not the easiest job in the world. You end up writing a lot of boilerplate to flush those events through and then fire things out. I think once you get a couple of those in place, it's not so bad. That being said, we have had some interesting or lackluster experiences with the Jest test framework, which is what Facebook shipped, I think, as a counterpart to React. I think one, they dropped support for Node 12, or they never supported it at all. Like they switched everything over to IO.js. There were a lot of headaches with getting any sort of coverage metrics put in place with that framework. I think what we found with that is that it's much easier to just use Jasmine with a test runner like Karma and write some of your own React util if you need it, or pieces out of Jest than it is to deal with that framework. Sure. Well, either one.
So it looked like the stores maintain their own state, like it looked like the list of folders, list of messages.
Yep.
How does the interaction work between, when an action that occurs, making an update to the server, like you mentioned, maybe marking the message as read, and then doing the same thing in the store? Does it like refetch the data from the store and then update? From the API, from the back end, and then update the store?
Yeah, so you could do it. I think if I understood the question, you could probably do it either way. So in our case, for something like clicking a message read, we might make an optimistic update to our store that says, hey, just mark this read, emit the change event, and then go fire the API request. Once the API request comes back, if the change succeeded, we don't need to do anything. If the change failed, then we could undo our internal state change, emit another change event. The views are all going to refresh the data, the messaging view is unread again. Does that kind of answer the question?
So I'm curious, we at my place, when we just switched from doing the API call in the store to doing it in the action.
Yeah.
Talk about why you switched it the other way.
Yeah, sure. So the big reason for us is that with the type of application we were building, it wasn't always necessary for us to make these API requests. So we needed some sort of a logic tier in place to look at the data coming in through our actions and the data that we currently have sitting within our own stores and figure out what changes we actually need to set off. So it felt much more natural to build that into our stores rather than in the action creators or the web APIs. That was the biggest reason. Now that being said, I can definitely see why it would be nice to have all data coming in from actions and start moving to some of these. I don't know if anybody's looked at some of the newer Flux libraries coming out right now. They talk about even their stores with pure functions and that all data just comes from the action creators and flows through at a time. We couldn't do that with this. So that is one of the trade-offs we made. Another trade-off with putting our API requests within the stores is that one of the big pieces that Flux architecture that they talk about in the Flux tutorials is sort of managing dependencies between stores, where a store might need to update itself while another store waits for that update to complete, then that store can update itself. We could never do that with this architecture because our stores aren't updating themselves until all of their actions have. So with that, I was just going to run through a couple kind of high-level lessons learned. Kind of what we saw as we were building this application. So we kind of hit on this earlier, talking about actions in the past tense. This one isn't necessarily a hard and fast rule. I think one thing it is important with these actions is that you agree on a common pattern for naming them and using them early on with your app, early on within your development phase. And then at the end of the day, we just want our actions to be semantic representations of what is going on within the app. The second one is more about React in general. Favor small components. Think about how you can build these small reusable parts. At the same time, it's really not necessary to oversimplify. We found some cases where we were building components that, when it boiled down to it, it was just pure HTML and CSS. That's great for people that hate writing HTML and CSS, but at the end of the day, it's not so bad to write 3 lines of HTML and create a panel with style. You might not need a React component for every single one of these cases. I guess the kind of the drawback to doing that is your file structure blows up really quick. It's hard to architectures. So next one, passing properties, or passing all data as properties and avoiding simplicity. So one thing, I don't know if we didn't really touch on it when we ran through that application, but all of the stores that we're defining and using within our app, those are all single things. So you could have any module in your code base, any view that is used anywhere. That view could go out and import that store, wire up its own change listeners, and grab data coming out of it. So, that's a completely valid case for those. We've actually done that a lot, but I think it poses problems, particularly as you want to start moving components around, or maybe packaging them up and reusing them in different ways that you hadn't done. Passing the property or passing all data down as properties really makes these things a lot easier to kind of isolate, reuse, as well as test. You don't have to create all of that state within the store just to wire up and test one of these views. Building stores around a single functional domain. So another one we kind of touched on. Stores can be more than just a single model or a single collection. They're more than they're a little bit of a larger representation of our data than something like a backend. These can represent the entire functional domain or area. So they might represent all of the data within our, within the mail portion of our application, as well as the state of what is presenting that data to the user. If we had something like a chat section on that application, now that might actually be a completely different small, because that is a little bit different. Keep store events simple. So one temptation that might come up as you're building these stores is that you might start wanting to fire unique events for every little thing that's going on. So maybe that's something like, for example, when we're saving data, we might emit a save started event, or a save failed event, or a save progress event, where you have some sort of progress indicator on display. That gets really complicated really quickly, and what your views end up doing right away is having to respond to changes in individual pieces of state, rather than just responding to changes in the store as a whole and grabbing state at the time. It's much simpler to think about your views just responding to change events and grabbing every piece of state that it cares about from the store rendered itself.
Could you rephrase that as pass almost the whole store state into prop?
You could.
How'd you go about it?
About passing the entire state of the store down as a prop? Yeah, sure. So if we look at the application we have, you guys see that, okay? So if we look at So if we look at something like our mail app, and let's say that we fired an event that said, the user clicked on a folder. At the end of the day, in our store, the only thing that changes is what our selected folder is, right? So our store, we might be tempted to just submit an event that says, okay, the folder, the folder changed event, which could result in our views just saying, okay, rather than just needing to go out and getting the state of the selected folder, or rather than even go out and get the state as a whole, I might only go get the state of the selected folder, merge the selected folder, merge that into my current state. So I think that works all right in small applications, but as you start building these out, you might find that you start adding new dependencies between items in your store. We're updating one item, or one action might end up triggering a couple different updates to your store that your views might previously not have been aware of. So it's much easier to just stick with it. What we found is that it's much easier to just kind of stick with just having it from the get-go and not paying ourselves to do that. Does that kind of make sense?
Yes, you're referring to what do not change.
Yeah. So just keeping, sticking with your change events and your error events. Don't try breaking your events down much more rapidly than that.
It sounds like you're running issues. You mentioned that one a couple of times. In that one, you get single updates. It seems that you're trying to resolve that by that state. We refresh the state and
Right. Yeah, and then that is a tough problem that the Flux architecture tends to solve very nicely. A couple more to run through. I guess this is kind of analogous to what goes hand in hand with what you just talked about. Avoiding the partial state updates on store. Letting the views ask for the entire state on every change event. Don't try to pull in just partial state updates and merge those into your existing state. That can be some headaches for you. Don't send data with events. So we talked about our stores. This is particular to events fired by our stores. We talked about our stores just firing change events. Then the views responding to that and saying, okay, now I'm going to ask the store for my data. I'm not going to take that data as input to my event. One exception to this case, I think, is with error events. Sometimes it is helpful to have a little bit of data fired off of that error event, so you might be able to do something with that. Show something like a flash warning or something. Favor all state and stores. So we've been harping on the idea of keeping all of our application data and state contained within the store.